Good evening, students. So yesterday we have seen some problems in the double integral, that is the block 2 we have started. Fourth unit we have completed. We have started the fifth unit. So fifth unit, in that we have seen one problem regarding of how to find a double integration. So multiple integrals is the block 2 we have. So transformations we have completed yesterday. So in that, we have seen the polar coordinates, spherical polar coordinates, cylindrical polar coordinates we have seen, and conversion of one coordinates to another coordinates. We have seen the some example problems also. Okay. So in double integrals, we have seen the how we will find the double integration, and one example problem we have seen. So double integrals in polar coordinates. So on this also you will get the problem. So whenever polar coordinates are given as a limit values for the definite integration, how we will find the double integrals? It is the concept we have. So if x equals to function of u comma v and y is a function of g u comma v, then double integration of f of x comma y dx dy is equals to, that is integration of f comma g. If two functions are there, how we will find the integration? Okay. So change of variable from Cartesian to polar coordinates. So if Cartesian, that is you have x comma y, then we have to convert them into r comma theta. Then we have to find the values. So on this we have the example problems are there. So next, change of order of integration is also there. So how we'll find the order of the integration? We have to eliminate the integral, changing the order of integration. So one check your progress problem is there. Evaluate the double integral 0 to a. So it is a unit 5 we have. So in this unit 5 we have. So unit 5, it is about the multiple integrals we have. So one problem we have, that is evaluate the double integral zero to a, and next one is 0 to root of a square minus y square x square plus y square into dx dy. Okay. So yesterday we have seen the limits only normal, that is the real numbers were there. There is 0 to 2 and 0 to 3. Here we have the limits in 0 to a and 0 to root of a square minus y square. Okay. So one limit for x is 0 to a, and for y the limits are 0 to root of a square minus y square. Okay. So for these, we have to convert them into the polar coordinates. So polar coordinates are the r comma theta, no? And we know that x equals to r cos theta, y is equals to r sin theta, and also dx dy is equals to r into dr d theta. And another one is x square plus y square equals to r square. So these all conversions you have to substitute in the given problem, and then you have to find the value for the given integral. Okay, let's see that problem now. So how we have to follow the steps, it is given in the textbook. So try to see those all steps. How to convert the double integrals in polar coordinates. So put x square plus y square equals to r square, dx dy is equals to dr cos theta. Okay, we have to substitute here in this x equals to r cos theta, y equals to r sin theta. Okay, and dx dy is equals to, if you do here differentiation, what will happen? Dx equals to dr into, that is cos theta differentiation is sin theta. So by that conversion, dx dy is equals to r into dr d theta. Okay. So these you will get with the help of doing the differentiation of dx and dy. Okay. And another condition, we know that put x square plus y square equals to r square. So already we know dx dy is equals to r dr into d theta. So here whatever the theta value is there, theta value is from 0 to pi by 2. Okay. So whenever we'll substitute here x equals to 0. So what will happen? X equals to 0 means r cos theta equals to 0. So whatever the theta value is there, the theta value, if it is 90 degrees, then you will get this value as 0. And here when you theta value is 0, you will get the value as whatever the y is there, that value you will get. So theta will be from changing from 0 to pi by 2. And from this relation, we can write x is equals to root of, here it is there, no, 0 to a square minus y square. So that whatever the x is there, one time x equals to 0, another limit is x equals to root of a square minus y square. So this you can write it as, if you do the square on both sides, that is squaring on both sides, x square equals to root will cancel, a square minus y square will get. Implies, if you take this one, x square plus y square equals to a square will get. Okay. So implies a square is equals to, what is in place of x and y, if you substitute cos square and that all values, what will happen? Or directly you can write x square plus y square equals to r square. It is r square. So cancelling the square on both sides, we get a is equals to r. Okay. Now substitute these all values, these theta limit values and also these 0 to a values here as the limits. So you will get it as theta equals to 0 to pi by 2. Next integration of r value is r equals to 0 and another one is a. Here we have no r equals to a and another r equals to, here we have no r equals to 0 to a. Okay. So now in place of x square, here it is there now. X square means r square cos square theta, r square cos square theta, and this is r square sin square theta. And what is dx dy? Dx dy equals to r dr into theta. Okay. So now we have to do the simplification of this one. So here the limit values are changing. Here 0 to root of a square minus y square is there. So here theta is from 0 to pi by 2 and another one is r value is from 0 to a. And by the polar coordinate relations, by substituting in the question, we can convert this into theta and r values. So now doing the simplification, we'll get it as cos theta is 0 to pi by 2 and r equals to 0 to a. If you take here r square common, r square into cos square theta plus sin square theta, one more r is there and dr d theta. So it is theta equals to 0 to pi by 2, r equals to 0 to a, r square into r is r cube. We know that cos square plus sin square is 1. So that is into 1 dr d theta. Okay. So first with respect to of r, we do the integration here. That is theta equals to 0 to pi by 2. R cube integration is r to the power of 4 by 4. That is 0 to a. dr has been completed. Only d theta is there. So it is equals to theta equals to 0 to pi by 2. In place of r, substitute a here. That is a to the power of 4 by 4 minus 0 into d theta. So it is equals to theta is equals to 0 to pi by 2, a to the power of 4 by 4. Okay. So here theta, any function is not there in the theta. Only constant is there, that is a to the power of 4 by 4. So into d theta. So it is equals to a to the power of 4 by 4 into theta equals to 0 to pi by 2 d theta. So d theta integration is, we know that theta you will get. So a to the power of 4 by 4 into theta and the limit values are 0 to pi by 2. Okay. Now we have to substitute the limit values as pi by 2 and also 0. Then you will get the answer for this one. So theta, if you substitute, it is equals to a to the power of 4 by 4. That is 1 theta value is pi by 2 minus 0. That is pi a to the power of 4 by 8. So this is the answer for the given double integration of the function by converting them into polar coordinates. Okay. So here in the question it is given x square plus y square, no? So we got one relation x square plus y square equals to a square. That means it is a circle, no? So like this we will get the diagram. Okay. This is x square plus y square equals to a square. Here a square is the radius, so it is 0, it is a, it is minus a, it is a, and it is minus a. Okay. So this is the figure representation for the given function. Okay. So it is a circle we have. So therefore we'll get this one. And here x values are x equals to 0 to a and y equals to 0 to a. So theta is from 0 to pi by 2. So how you will get theta value as 0 to pi by 2 means? Okay. So theta is from 0 to pi by 2. So with the help of this, we can find the problem. So next we have change of order of integration. The concept of change of order of integration evolved to help in handling typical integrals occurring in evaluation of double integrals. So for solving any double integration, if any problems are occurring, then change of order of integration has been introduced to make it in a simple way. Okay. So for this one, you have one problem. Example problem is also there. So we know that today is the last class now. Somewhat lengthy problem. So we'll go to the unit 6. You can see the example problem in the textbook. So see that problem. Next, if you'll go to the unit 6, we have the evaluation of triple integrals. Triple integrals means you will have x1 to x2, y1 to y2, and z1 to z2. Okay, z limits are either constants. So evaluation of triple integrals, you will have some conditions will be there for triple integrals. You can see those conditions. So unit 6 is evaluation of triple integrals. So triple integrals will be like this: x1 to x2, y1 to y2, z1 to z2, then f of x comma y comma z dx dy dz. Okay. So the given problem will be like this. So for such type of problems, first z limits are either constants or functions of x and y. Here z limits are there, no? These will be in some case they will be constants, or in some case they will be functions of x and y. Okay. Similarly, y limits are either constants or functions of x. Okay. Z will be the functions of x and y, whereas y you will get the either constant values will be there or functions of x will be there. So x limits are either, that is you will get x1, x2 or constants here. So first z integrated, then y, and then last x. So first whatever the z of in the given function, what is the z value, z term, that z term is first integrated, then substituted the limits. After that y, after substituting the limits and simplification, next last we have to go to the function x. So that is the procedure how to find the evaluation of triple integrals. So these all whatever the definition is there and formulas are there, those you have in your textbook. You can check there. Now we see one problem. So like this, only constants will be also given. Evaluate x equals to 0 to 1, y is equals to 0 to 2, and z equals to 1 to 2, x square yz dx dy dz. Okay. So this is the given function we have. So first we know from this condition is that first z we have to integrate, then y, then x. So here all constant terms are there. There is a constant limits are given for the x, y, z. Okay. So this one directly we can do. So integration of x equals to 0 to 1. Next, y equals to 0 to 2. Whatever the other terms are there other than z, you can take them as constant. That is outside the integration. We can take them x square y. If you take outside, then integration of z equals to 1 to 2 z into dz of dx dy. Okay. So it is equals to x equals to 0 to 1, y equals to 0 to 2, x square y. So integration of z is z square by 2. And here the limits are 1 to 2 and dx dy. Okay. So if you substitute z value as 2, 2 square is 4, 4 by 2 is 2 you will get. X equals to 0 to 1, y equals to 0 to 2, x square y. So 2 square is 4, 4 by 2 is 2 minus 1 we have. So 1 square is 1, 1 by 2. So dx dy. So it is dx dy. Now if you do the simplification of this one, 2 2s are 4, 4 minus 1 is 3. That is we get 3 by 2. So x equals to 0 to 1, y equals to 0 to 2, x square y, and this is 2 to the 4, 4 minus 1 is 3. So it is 3 by 2 we have dx dy. Okay. So 3 by 2 you take outside, x equals to 0 to 1, 3 by 2, integration of y equals to 0 to 2. We can take even x square also outside, only y dy into dx. Okay. So it is x equals to 0 to 1, 3 by 2 x square, and integration of y is y square by 2, and here 0 to 2 limits and dx. Okay. So it is equals to x equals to 0 to 1, 3 by 2 x square. If you substitute 2 means 2 square is 4, 4 by 2 is 2. And when you substitute 0, you will get it as 0 only. Okay. Now this 2, 2 both will get cancelled. It is equals to 3 if you take outside, integration of x equals to 0 to 1, x square into dx. So it is equals to 3. X square integration is x3 by 3, 0 to 1. So 3 into 1 if you substitute 1 by 3. Okay. And 0 if you substitute, you get 0. 3, 3 if you it's cancelled. So the answer is 1 here. Okay. So like this, we have to solve the problem when triple integrals are given with the limit values as constants. So this is the procedure. So one more problem is there whenever constants are not given. So either you have the functions of x or the functions of y. How to solve the problem? We'll see one problem on that. So this by this we complete the unit 6. So unit 7 is about, so by unit 6 we complete the block 2 here. So next we'll have the block 3. Block 3 is vector integration is there. Okay. So last problem in unit 6 is So one more problem is evaluate 0 to 1, y to 1 and 0 to 1 minus x. Okay. So x into dz dy dx. So this is the given function we have. So here this is the x value, this is the y. These are the x limits, these are the y limits, and these are the z limits. Just in the introduction, we have seen z will have the functions of x and y will have the functions of either constant or x will have. Okay. So by this, we can see that z is having the function of x. So for this, so 0 to 1, keep like that only, y to 1 also keep like that only. So x is there, you take outside, then here 0 to 1 minus x, dz we have, and dy and dx are, here we are taking them as constant. So it is equals to 0 to 1, y to 1, x. So dz integration is z we have, and here the limit values are 0 to 1 minus x dy dx. Okay. So it is equals to 0 to 1 by to 1 x. So one limit is z value is 1 minus x, another one is 0. That means x into 1 minus x dy dx. Okay. So it is equals to integration of 0 to 1 and integration of y to 1 x into, that is if you multiply x with that, x minus x square dy by dx. Okay. So now we'll do the differentiation of this one with respect to of dx. So you will get it as 0 to 1 x in your x integration is x square by 2 and x square is x cube by 3. Okay. Next we have dy is there and this is y to 1 into dy. Okay. So it is equals to 0 to 1. When you substitute here upper limit as 1, you will get 1 by 2 minus 1 by 3. Next minus of lower limit, that is minus y square by 2 y to the power of 3 by 3 into what we have dy. Okay. Here if you have any confusion, you can take dx here first and dy later. Okay. So now here 1 by 2 minus 1 by 3 means if you take the x denominator as 6 as the LCM, then we'll get this value as it is equals to 0 to 1. It is 6 now. So 6 to 3 times minus 2 times. 3 minus 1 is 3 minus 2 is 1 you will get. That is 1 by 6. This is 1 by 6 minus y square by 3 into dy. Okay. Now we have to do the integration with respect to of y. So here see, this is the y value we have from 0 to 1, x value is from y to 1, and z value is from 0 to 1 minus x. So these are the limits of the functions. So first you have done the integration of z and we have substituted the limit values. After substituting the limit values and after doing the simplification, we got the whatever the function is there, that function we got in x. So we have done the integration with respect to of dx. So after finding the integration, we have substituted the limit values as y to 1. Upper limit is 1 and lower limit is y. When you substitute in the whatever the resultant function we have got, so there you will get this as the simplification. So again, whatever the terms are there, those terms are in the y function. So we are doing the integration with respect to of y. Okay. So when you do the integration with respect to of y, so it is equals to 1 by 6 into y minus y cube by 3 into 2 is 6 minus y to the power of 3 is there. So in integration, we know that integration of x to the power of n into dx. So remember these formulas. Okay. Integration of x to the power of n dx is equals to x to the power of n plus 1 by n plus 1 plus c. Okay. So by this integration, we are finding wherever the x square is there or x cube is there or x to the power of 4, whatever the values are there. When you substitute this formula, then we are getting the answers. Okay. So try to practice all the integration formulas for x, y, and also sin x, cos x, tan x, and even inverse integration will be there. So with the help of that also, we can find the problems. Okay. So this is y to the power of 4 by 4 into 3 is 12. And what are the limit values? 0 to 1. Okay. Now we have to substitute the upper limit and lower limit here. So when you substitute the upper limit, what you will get? In place of y, substitute 1. So 1 by 6 minus 1 by 6 minus 1 by 12. And when you substitute 0, these all values will become 0. So it is equals to plus 1 by 6 and minus 1 by 6, both will get cancelled. So what is the answer? Plus 1 by 12 by b square. Okay, see here. Upper limit when we have substituted is 1 by 2 minus 1 by 3. When we have substituted lower limit, it is minus by square by 2, minus of minus is here plus. Okay. So it is also plus. It is also plus. It is also plus. So the answer is here 1 by 12. Okay. So like this, we have to find the problem whenever the triple integrals are given with respect to of the three limit values. Okay. So by this, we are completing the unit 6, and that is second block also we are completing. So from this, almost whatever the problems I have told, they are definitions are there, some theorems are there, some exercise problems are there. Those we will get for 5 marks question and also 10 marks questions. So 2 questions short answers will get, and 2 questions you will get the long answers from the block 2. So next, if we'll go to the block 3, we have the vector integration is there. So unit 7 is line integrals and surface integrals. Next, unit 8 is about the volume integrals and application of volume integrals. And unit 9 is about the curvilinear coordinates. Okay. So what are the line integrals and what are the surface integrals? So there is definitions you have in your textbook. You can go through them. So just a representation of what is the line integral and what is the surface integral. If you know that, it's enough for solving the problems. And even whatever the block 4 we have, whatever the block 4 we have, in that block, you have the theorems are there. So if you know the concept of the surface integrals and also line integrals and even the notations are, if you know, then you can prove the theorems, those three theorems. So the concepts, whatever you are learning in the block 3, those are useful for solving those theorems. Okay. So line integration means when a curve R of t equals to x of t vector I plus y of t j plus z of t k passes through the domain of a function f of x comma y comma z in space. The values of f along the curve are given by composite function f of x of t, y of t, z of t. If we integrate this along the curve from t equals to a to t equals to b, then it is called the line integral of f. So this definition you have in your textbook, you can go through that. A line integral is an integral where the function to be integrated along a curve. Surface integral is an integral of a function of two variables. So in the surface integral, you will have the variables 2 over a given surface. So just we'll see what is the line integration notation.
Good evening, ma'am.
Good evening.
Ma'am, could you tell me some important questions in discrete mathematical structures, ma'am?
Some other Sari is telling no DMS.
Yes, ma'am, but the class was not going, ma'am.
No one is taking the class. Huh?
Yes, ma'am.
Today is the last class. No?
Yeah, ma'am.
You are from Hyderabad or any other district?
No, ma'am, from Karnool, ma'am.
Kurnool. So DMS means so classes are not being conducted. No one is
No,
taking.
no one is taking class, ma'am.
These are the live classes, no?
Yes, ma'am, but daily no one is taking classes, ma'am.
Okay, just wait. I will see the test. So you have taken the elective of that one, DMS you have taken,
Yes, ma'am.
You would have chosen the vector calculus, no? If you are intermediate student, it is easy for you, no?
Yeah, ma'am, without any idea, I just choose that subject, ma'am. I don't have any idea.
Before filling the examination form, you would have the chance of changing, no? No chance was there.
No chance was there, ma'am. After knowing that, I just realized it will be better for me to take vector calculus, but there was no chance for me, ma'am.
Okay. You have test book.
Yes, ma'am.
Starting, you have all the statements are there, no? And the condition, disjunction you have.
Yes, ma'am.
So those all, whatever the definitions are there, tautology is there, contradiction is there. So on this only, you will get the 5 marks questions and even 10 marks questions also you will get from this one only. So
Okay, ma'am.
first you see in the first unit what are the definitions are there and how you will represent them. Okay. Main
Okay,
thing
ma'am.
1.5 tautology is there, no?
Yes,
So
ma'am.
on that you will get the questions and it is the important one for 5 marks. Means just here in the first unit introduction is given, but in the latter units you will get even this on this concept you will get the 10 marks questions also.
Okay, ma'am.
Okay, definition you have in 12th page number 1.5.2 it is there. Okay,
Okay,
so
ma'am.
progress problems also you see once. Same 12th page number 1 is there, no?
Yes, ma'am.
Okay, 15th page number, if you'll see, starting fourth question is there, no?
Yes, ma'am.
Fourth and fifth question.
Yes,
So,
ma'am.
almost the questions will be like this only. Third question, fourth question, fifth question, and even in the long answers. Truth tables will be there, no? Construction of the truth tables.
Yes, ma'am.
You get all, whatever the relation is given in the question, if we get all the true values, then we say that it is satisfying the condition of the tautology. Okay. So
Okay.
only in some cases they will ask only to, that is a truth table they will ask, or they will ask to show the relation also. So problem will may be asked in any way. That is about the first unit. See, even in the 17th page number also, you have the tautological implications are there.
Yes, ma'am.
That is example is there, no? The propositions P to Q and negation of P, that is V, Q are logically equivalent. This is the important one. You will get for 5 marks question. 2.2.2 is there, no?
Yes, ma'am.
And then, so these laws are there, no? Equivalent formula. So you can go through them.
Okay.
This is the they may object if I'll tell the DMS in the vector calculus. Okay, you can take my number and afterwards can you call me?
Okay, ma'am. You can chat me or you can message me, ma'am, in this only.
Okay. So here in the whatever the links they will give, no, they will give the even phone number also, no.
No, ma'am. They didn't give it, ma'am. So you can chat me in that box, ma'am. Message box.
You know, you just to make the WhatsApp. Okay, I will
Okay,
give the.
ma'am.
I will tell what are the important question afterwards. Okay. So
Okay,
who
ma'am.
is class? No, they will tell why in vector calculus class they have told the DMS. No, it is some other
Okay.
SAS. So
Okay, ma'am.
57214. Okay, this is my number.
Okay, ma'am.
Okay.
Thank you, ma'am.
Okay. So line integrals notation is there. So line integration notation is, it is the unit 7. So unit 7 is line integrals and surface integrals. And surface integrals. So here, whatever the line integration is there, that notation is line integral notation. So that is, in a sense, what is the representation of the line integral? So we that is integration of f dot dr is equals to f dot dr is equals to integration of f1 dx plus f2 dy plus f3 dz. Okay. So this is the representation of the line integral. So whatever this representation is there for the line integration, we will use this concept in solving the Stokes theorem. Okay. Line integration notation is used in solving the Stokes theorem. Next, if you go to the, that is we have seen the conservative field and also irrotational conditions in the second block, not in the second block, in the first unit, first block, second unit we have seen, no. So there irrotational is there, solenoidal is there, that is a gradient. We have seen the definition of gradient, divergence, and also scalar of a function we have seen. So there in the definition, if a force field F is conservative, if and only if it is a gradient field. Okay, condition is given, and a force field F is a conservative field if and only if del cross F equals to 0. That is, F is irrotational. This is the, for the scalar point function we have seen the curl of a vector, divergence of a vector, curl of a vector, and also gradient of a vector. There we have seen the definitions of conservative and also irrotational. So with the help of these concepts, if any question is asked to show that the irrotational or conservative field, you can use those concepts. Next, if we go to the surface integral notation, surface integral notation is surface integral notation. Okay. So in this integration of, So here you will have the double integration will be there. Double integration of S f of x comma y comma z into ds, or flux we call it as. So that is double integration of S f dot n ds is called flux of f over s. Flux of s over s. And this, whatever the concept is there, the surface integral we use for the Gauss divergence theorem. Okay. So for solving that, we use this one. So whenever the surface integral notation is there, so with the help of that, we'll find the problems also will be there. 5 marks question they will ask for finding the problems, evaluation of surface integrals. So a Cartesian form of the surface integral will be there. Whatever the f is there, that f is equals to f1i plus f2j plus f3k, where f1, f2, f3 are continuous or differentiable functions of x comma y and z. So whatever this is there, this we can write it as in double integration of s f1 cos alpha plus f2 cos beta plus f3 cos gamma, okay, into ds. Okay. So whatever this cos alpha, cos beta and cos gamma are, they will be converted into, this is equals to double integration of s f1 dy into dz plus f2 dz into dx plus f3 dx into dy. Okay. So whatever here cos alpha is there, this is this one. And whatever the cos beta is there, it is dz dx. And also whatever the cos gamma into ds is there, that has converted into dx into dy. Okay. So with the help, if you know the notation of the surface integral, we can find the problems. So problems will be asked on surface integral and also line integral. Even 5 marks problems will be there and also 10 marks problems will be there. So these are the concepts, and see once the problems on this one. So after unit 7, we have unit 8 is there. Unit 8 is about the volume integrals. Suppose V is the volume bounded by a surface. Divide V into subvolumes delta V1, delta 2, delta V2 up till delta Vn. And the volume integral will be, the notation will be like this. So triple integration will be there. V f into dv. Okay. So this concept also we use for the Gauss divergence theorem. That is, whatever the surface integral is there, f dot n ds is equals to the triple integration of f into dv. So that is a divergence will be there. So through this notation, we can find the problems for the volume integrals. So on this also you have example problems and exercise, and even MEQ questions are there. So try to practice those all problems. Last, if we go to the block 4. So in these 3 theorems I have told, those 3 theorems are very important. So you have the chance for getting the 10 marks question and also 20 marks question. So section C is 20 marks, no? So you have to state and prove the theorems. And on this, verification of the theorems also will be there. That problems also will be asked for 10 marks question. It is integral theorems. Okay, block 4. So unit 10 is about, I'm writing all the units here, unit 10, 11 and 12. So first we have Green's theorem. So the question will be state and prove the Green's theorem, or if he is asking for about the problem he is asking, he will ask verify the Green's theorem or verify the Stokes theorem or verify the Gauss divergence theorem. Okay. So Green's theorem is whatever the definition is there, statement definition you can see from the textbook. Let A be a closed region in xy plane bounded by a simple closed curve C. Let m of x comma y, n of x comma y be the continuous functions having continuous partial derivatives in R. Then, so just I am writing the notation of this one. That is with curve C, m into dx plus n into dy is equals to double integration of R dou n by dou x minus dou m by dou y into dx dy. Okay, where C is the transverse in positive direction. Okay, but main thing is showing here right hand side and left hand side both are equal. For the even for the proof and also statement, you have to write the statement this one, then you have to solve the proof. One diagram will be there. So this whole thing, whatever will be there, if you complete that, then it will be given for the 10 marks question. So they will give the 10 marks if you write the statement, diagram, and also the proof of this one. If it asks for even 20 marks, they may give the state and prove Green's theorem and one more combination, verify the Green's theorem. So you have to show your right hand side is equals to left hand side for verifying the theorem. Next we have the Stokes theorem is there. Stokes theorem. So Stokes theorem, we have seen the line integral, no, f dot dr is equals to integration of curl f dot n ds. Okay. Where n is a unit normal vector at any point s. So this whatever the Stokes theorem is there, this gives a relation between this is the surface integral and this is the line integral and this is the surface integral. So this whatever the theorem is there, it gives a relation between surface and line integrals. Next, if we'll go to the Gauss divergence theorem, Gauss divergence theorem. So here also state and prove the Stokes theorem and verify the Stokes theorem will be asked. So if it is the Gauss divergence theorem, it is one of the most important theorems of vector analysis. It reduces a surface integral to a volume integral here. So we have, so this is the relation between line and surface integral. And Gauss divergence, you have the relation between the surface integral and also volume integral. That is double integration of S f dot n into ds is equals to triple integration of V div f into dv. Okay. So double integration of S, that is f dot n. F dot n is the surface integral and this is the volume integral. So the relation between these two will give the Gauss divergence theorem, and the question will be asked, state and prove the Gauss divergence theorem or verify the Gauss divergence theorem. So these three theorems are very important. So you have three sets, no? Set A, set B, set C. So in one set, you will get one theorem, or the problem regarding of the three theorems you will get. So this is about the block 4 integral theorems. So you can see whatever the important problems are there and important theorems are there from the textbook and practice the problems.